Yeah, 4 over 4 cos x. 4 over cos 4x. Okay, 8 part 2 has then given us this massive integration question to do, which looks quite horrendous, and I think took me a little while to think about how the best way to work through it was. The method I ended up using was to add these two fractions together to get a common denominator, and the reason I decided to do that was because we've got a difference of 2 squares on the bottom here, and I thought maybe that's on purpose, and maybe they've made those two like that for a reason. So I wanted to go with that difference of 2 squares method to see if it made things useful. So let's see what happens. We need to make the denominators the same, so we need to times this cos 2x by this denominator here. So cos 2x times by cos 2x, take sine 2x. The sine 2x is going to need to be times by the cos 2x plus sine 2x. And then that can all now be over this times this, and because it's a difference of 2 squares, we can straight away write cos squared 2x minus sine squared 2x. If you multiply these two together, the sine 2x, cos 2x terms will cancel each other out. So that's why we've just got sine squared 2x from this times this, minus sine squared 2x from that times that. So now let's tidy the top up. What have we got going on the top? We've got cos squared 2x here. We've got a minus cos 2x sine 2x. We've got a plus cos 2x sine 2x as well. So they're going to cancel. And we've got a plus sine squared 2x. And that's over cos squared 2x minus sine squared 2x. So these middle terms will go, leaving us with sine squared 2x plus cos squared 2x, which is 1 again. Sine squared plus cos squared is always 1. Over cos squared 2x minus sine squared 2x. Now it's not straight away obvious what to do with this, unless you know your addition formulae and your double angle formulae really, really well. Cos 2x is equal to cos squared x minus sine squared x. If you use your cos A plus B and swap A and B both for x, this is what pops out. So that's what we were meant to spot next. That because this is cos squared 2x minus sine squared 2x, we've got a version of this formula here. Sine squared 2x is going to be equal to cos 4x. And that's what we need. So we can now just change that denominator to cos 4x. So that's a really important step. So we've taken it all the way from all of this mess. So we're going to be wanting to integrate these and ending up here. But how do we integrate that? We can't normally integrate this, but what was part 1? Part 1 was to show that if you differentiate this log thing, we get 4 over cos 4x. And that's just 4 times bigger than our question. So if we now want to integrate a quarter of this, our answer is just going to be a quarter of this. So that's the integration done. It's just going to be a quarter of the question from part A. 1 plus sine 4x over cos 4x. So even though this question is technically an integration question, don't forget your plus c, even though it's technically an integration question, I think this was all set up to test your knowledge and understanding of the addition and double angle formulae. So that's what we were looking for part 2.